So the first thing that we had here is finding the midpoint of each side of the triangle. When we first did it, you had a graph. We had the XY plane. You could count. We actually counted the slopes. We kind of did it that way. Long term, that's not going to be how we would always be able to do those on an XY plane. But what we're looking for is the point, let's say in this case, directly in the middle of segment OT. And since that's our first one, that's the one we're going to do first. So eventually we kind of worked our way through and we came up with the midpoint formula. So there is a formula that we could then use so that if it's not graphed on an XY plane where we're going to be counting and everything, we can still do this. So the midpoint formula, let me not use M, let's do this as an abbreviation. The midpoint is going to equal, if you remember, we added the x's together and then cut those in half. All that's really doing is an average, right? You add up two numbers, divide them by 2, we're just averaging those values together. That should put us right in the middle. And then comma, and then you do the same thing with your y coordinates. You're going to add those up. We're going to basically find the average of the two y coordinates. So for segment TO, if I'm going to do that for segment TO, the x's in those two coordinates are a -1 and 3. So we're going to be adding those up and then cutting that in half. And then you're going to do the same exact thing with your y coordinates. So the y coordinates of those 2 points are 5 and -2. So we're going to add those up, divide that by 2, and that again should give us the average of our x's and the average of the y's. So when we do that, midpoint of TO, this should be 2 divided by 2. So that would have given us a 1. 5 plus a -2 would give us 3 divided by 2. So you can leave that as a fraction. So if you write it as 3/2, that's totally fine. Or we can go ahead. A lot of people like the decimals. They tend to make a little more sense anyway in terms of if it's reasonable. Or you can do that as 1.5. That was our midpoint formula. All right, add up the x's, divide by 2. Add up your y's, divide by 2. Those are your new coordinates. So the next one, what is the next one? OM. Come on. Here. Same exact process. We are going to, too many markings I'll keep track of here. We are going to add the x's up. So that would be 3 and 7. Divide by 2. You're going to add your y's up, the 5 and the 1. Divide by 2. This should give us 10 divided by 2. So that's a nice number. 6 divided by 2, also a nice number. And our midpoint should be 5, 3. All right, good. All right, do the last one real quick. It's not necessarily hard stuff. We just had to remember the formula from a month ago when we did this, probably. I think I've used for it before. All right, what'd you get, Cam?
3, -0.5.
Good. So he said 3 was the x coordinate. And then it's up to you again. If you write it as a fraction, totally fine. I think most people do like the decimals because it makes more sense in our heads. 3 -1/2 or 3 -0.5. All right, so that's our midpoint. That's something long term that you see a lot on standardized tests too. That's one we want to kind of file away and then know. All right, next one. Use the diagram of triangle ABC where D, E, and F are the midpoints of the sides. So this is a midpoint, this is a midpoint, and this is a midpoint. All right, do 4 and 5. Go ahead and fill those out. Even if you don't remember why, it should be kind of obvious if you look at the picture and understand this means parallel. Let's make sure we're clear on that. These two lines next to each other are parallel. So what that number 4 is saying, segment DE is parallel to what segment? There is a theorem that goes with this, but by just the way the question is written, that DE is parallel to something. The theorem is that if I have a line segment that connects the midpoints of two of the sides of a triangle, then it has to be parallel to the third unincluded side. If you don't even know that, there's only one legitimate answer here, correct? That makes sense. What is it, Ahmed? Yeah, the only one that it could possibly be parallel to is BC. So whether we remember the theorem or not, just a little common sense, some number sense would give us that answer. Same with FE. Even if we don't remember the theorem, if we know this is FE, but again, the theorem is if this connects two midpoints of two sides of a triangle, so that would be this side and this side, then it has to be parallel to the third side, which again would be the only one that would make any sense. So that would be BA. All right. The next two, do those. Those should also be nice, hopefully. Especially 6 and 7. And then definitely pick an Alpha for 8. Actually, all of these. These are a little trickier than I thought. At least one of them is. Okay, remember this stuff, Ella? Yeah? All right, so AB, I tell you here. Uh-oh, come on, you. There we go. So AB is here, and that's 14. And then I want to know EF. Ella?
7.
See, you did remember it. Good. That has to be 7. All right. So it's one of the things, if we have this triangle, that segment that connects our midpoints is always 1/2 the side that it's parallel to. So since these are parallel to each other, this has to be 1/2 of that parallel side. So EF must be 7. All right. When we go to AE, it's really similar but different at the same time. Same thought process, but a little different in the sense if I now tell you that AE right here is 7, or 8, yeah, thank you, 8, then DF here would have to be, Cam?
8.
Good. And what was your thought process there?
They look like the same size.
You can't just say it look like.
I like that though. In true geometry, when we used to teach true geometry, that was kind of a theorem that we don't use as the look like theorem. But you're right. This is 8, 100% 8. If this is the midpoint, doesn't this also have to then be 8? Right? This is the midpoint. So it's right in the middle. So if this side is 8, this side is 8. So isn't this whole thing 16? And then the same theorem that we just used, doesn't the parallel side have to then be half of that full side? So that's how we can know for certain that it's an 8. Okay, so you are right. And then that's sort of our thought process we would want to use. Okay, and then DE is what? 6. B. All right, this one's easy. Vicky, what do we got? Good. That's pretty straightforward. This side is half of its parallel side, so that's got to be 12. All right. So that was that little midpoint theorems of a triangle. Now we'll do some algebra with these same exact theorems of the two above, but now just algebra. We're going to have to do some equations and some solving equations. So it says use a diagram of triangle MNO. X, Y, and Z are your midpoints. So X, Y, Z are the midpoints. And then now instead of giving you numbers and you're just going to solve these with numbers, you're given a variable expression. So YZ, YZ. This is 3x plus 8. I don't like algebra. So that's 3x plus 8. I don't know if I can write sideways though. So 3x. There you go. And that's this side here. And then mn is 10x plus 4. mn. Okay, good. I labeled that wrong. That threw me off for a minute. I was like, how? There's a bit of a panic there, Vicky, because I was like, I don't know how to solve this problem right now. Because I drew it wrong. So let's do YZ. I was hoping I screwed up, and I did. So good for me. So this is a 3x plus 8 here. That's YZ. So definitely label that. And then mn, this whole side is 10x plus a 4. All right, now we can solve this. Now we know how to solve this one, Cam. Question, or are you going to tell me what we could do?
Like a question, but
Sure.
well, I'm going to tell you what I think.
Okay.
Can we just set up meetings with each other?
Now let's use the lookalike theorem that you like to use, Cam.
Okay.
So does this segment look to be the same length as this segment?
No, it looks like we have.
There you go. Right? Isn't that our formula? If this was 7, wouldn't have you told me this is 14?
Yep.
So this is half of that side. So you can do one of two things. The way we did these when we did these, and it was a long time ago, if this was 7 and this is 14, don't I need 2 of these guys to make one of those guys? So what I had you guys do is take that 3x plus an 8 and double it. And if I double that, doesn't that then equal the big longer side, which is 10x plus a 4? Okay.
I also do like 5x plus 2, and just split that in half.
Okay, that was the other one. You understand that one, Cam?
Yeah, that's
Okay. Or somebody in here said, same same thing, but we're going to kind of do the opposite, but the same rule is, let's say I keep the 3x plus 8 the same. Doesn't that equal 1/2 of this one? So I could cut this one in half and then set it equal to the shorter one. Do you understand how those are the exact same thing?
Yeah.
So now you can solve either one of these two equations. They're going to give you the exact same answer. Okay. I don't like the fractions. I tend to people don't like fractions, especially, this isn't bad because these are nice even numbers. If those are some odd numbers and we're cutting in half, then we start creating fractions and decimals, and just people tend to not do quite as well with those. So that's why I like to double, and then we avoid the fraction issue.
Okay, I see what you mean by that.
Yeah, in this case it wouldn't have been bad, but that tends to cause some issues. So distribute, and then we're just going to go through, solve that equation. I didn't leave myself enough room here. So that should cancel. Where am I going to do this? Move this over.
just slowly starting to come back.
It's been a while. It's been a long while. So we get 16 on the left, and then this should give us 4x plus a 4. Subtract the 4. Divide by 4. Then after all that work, it's easy to think that's your answer. If it's multiple choice, 3 would probably be one of the other distractor answers. 3 is not our answer though, right? We ultimately want the length of YZ. Here is YZ right here. So YZ is 3 times x. We now know x is a 3. So to find YZ, I now need to take that expression 3 times x plus 8 and plug in the x value that we just solved for. So what is that? 9 plus 7 or plus 8 is 17. All right. All right. So with that, set up the next one. It's largely the same. I don't know if we'll go through the whole problem and solve it, but see if we can at least set it up. let's see if you want to finish solving it, feel free. You were given that y-x is this 3x minus a 4. And then, not coincidentally, we were told the side that it is parallel to, this MO, this whole segment is 9x minus a 20. So pretty much the same rule now for the third or fourth time today. Second one with an equation. That 3x minus a 4 is half the size of the 9x minus 20. So to make those guys really equal to each other, we would need to double the smaller one. And when we do that, that would equal the bigger side of 9x minus 20. All right, we go to that. Okay. A lot of you are solving this. So we get what? X is 4 and X is 8. 3x.
No, I'm saying for MO.
Oh, if X is, what did I say X was? 4?
Yeah.
You get 18, don't you? Find MO. Here's MO. So let X be 4. What's,
Oh, I thought you meant Y.
Yeah.
you get 16, my bad. 16.
Yeah, I thought you did.
Because you would do 9 times 4 is 36, minus a 20, you would get 16 for the answer. Okay? All right, let me read. Yeah, we got these guys. So you remember this. This has been a while, too. All right, it says, if you remember this symbol, remember how this meant similar? So triangle, or whatever this is, quadrilateral ABCD is similar to WXYZ. And then it says find the scale factor. So recall, if A and B are next to each other, so here's AB, that corresponding, you see what this is? Yeah, but my pen's jumping all over the place on me. So watch this. I'm gonna draw that, and then it goes away. It's weird. Yeah, right. So go ahead and do this. To find the scale factor, watch this, and then it's gonna go away. Let's see, and it shows up on directions. So do we all agree, see if I can write this real quick, that AB and WX are corresponding sides? They're the first two listed. So if I hurry up, and you guys do this, because I'm going to shut this down and start it back up, the Word document here, shouldn't this side and this side, those are the ones that we can set up a ratio for, a fraction for, and then figure out what their scale factor is. All right, so do that. 3.5 to 7. Write that as a fraction. And remember, we're going from the smaller one to the bigger one. There we go. So smaller to bigger. So we're going to go from the small quadrilateral to the bigger quadrilateral. So when you set that up as a fraction, you can do it 3 different ways. We said we could use the word 2. You can write it with a little colon, but we tended to do the 3.5 to 7. So isn't quadrilateral ABC, wouldn't all of these sides be 1/2 compared to the other side? All right. So with that knowledge, we should be able to solve all of these. If this is 8, T has to be what? 16. If this is 5, so the side on the bottom is 5, this side has to be 10. The one on the left is always half the size of the one on the right. And then side S has to be 1/2 of 9. Yeah, so that's 4.5. All right, so that's, once we establish that, then we can figure out all of those sides. Then, back in the day, I had you actually find the perimeter of these. Remember, you would add all these up, add all these sides up, and then we wrote them as a fraction. But do we remember how it ended up being the exact same thing as all of the sides? We don't need to do that anymore. We can just say that the ratio is going to be 1/2 of the perimeter as well. All right.
Well, I already found the formula.
You could. Did you write them as fractions then?
I felt like 21.
And isn't 21/2 of 42? Yeah. So if that's what we did before, you can absolutely still do it. But we now know that we don't necessarily need to do it because it's going to be the same ratio as the sides. Okay. All right, then these guys. State whether the following triangles are similar. If yes, state the theorem that would prove the triangles similar. I got to refresh my memory a little bit. So we know we have angle, angle. That's a good one. Similarity. Yep, side, side, side. And then, yeah, side, angle, side. So those are our three things.
Look it up, remember.
That's right. I was even like, let me make sure I don't screw these up. So those are our three, and it basically is going to be, what are you given? If you look at this first one, you're given all of the sides. So more than likely, we're trying to prove this right here. All the sides should have the same ratio to each other. So if I took 6 and I compare that to its corresponding side of 15, we want to reduce this all the way down. 3 goes into both of these. 3 would go into 6 2 times. 3 will go into 15 5 times. So all of these sides would have to have the same exact ratio when we reduce them. So for our next ones, I'm going to take the 10 and the 4. We're going to write those as a ratio, and we have to do it in the same order, small over big. If I divide those by 2, that also gives me 2 over 5. So far, so good. The last ones, we compare the 8 to the 20. And do we get 2/5? Yeah. So all of those are 2/5. So the first thing it says is state whether or not they are. So that is a yes. And then it says state the theorem that would prove that. It was the side, side, side similarity statements. Okay. When we go to the next one, based upon what we were given, more than likely, we are now looking at side angle side. That's kind of what we want to see. So clearly we have, well, let's talk about this. The angle has to be in between your two sides. So those sides correspond to each other. And then this side and this side correspond to each other. Is the angle in between them, are those congruent? Yeah. So the angle had to be in the middle, and this is. So now all we really need to now identify is the 18 compared to the 15 going to give you the same scale factor or ratio that the 12 to the 10 would give us? And if they do, then we're good. So yeah, 3 goes into both of those. And you can do this on your calculator too, if you don't know that. That's a 6/5. 2 goes into both of these. It goes into 12 6 times, 10 5 times. So this is also a yes, and this would now be the side angle side statement. Right. All right. See what you think about 16. All right. With 16, are we given any side lengths whatsoever? No. So pretty much these two, we can't even consider those because we don't know what the lengths of any of those sides are. So it's really, can we satisfy this or not? If it's yes, then you're going to use this. If we can't, then we would say there's not enough information. We don't know that those are similar. All right. Ahmed, you were chomping at the bit there. What do you think? Can we prove this or no?
Yes, we can.
And why can we prove this?
Because both angles are
Good. So we agree we agree that these are congruent. That's easy. All right, it's marked for us. So there's one of the A's that we need. We don't have a second angle that's marked that they're congruent to each other. Yeah, but what he mentioned was the idea of vertical angles. So when two lines intersect, remember how we form these four angles? Remember vertical angles, the angle across from each other have to be congruent. So 2 and 4 are congruent, but those don't do us any good because they're not in the triangles that we're concerned about. But does an angle 1 and angle 3 have to be congruent also? So these guys are also congruent. Do these in blue here. So that's congruent to that. So we do have two angles that are congruent. We've satisfied this. So this is a yes. And then that's the angle similarity statements. All right. All right. So we'll do two more. Try 17. See if you remember these guys. So it says using the figure, complete the following proportions. So you're going to say EF compared to FG. Actually, before I mark it up, see what you can. I think once I mark it, we'll know. All right, so EF is in red, and then that is compared to the F and the G. And then, so the numerator I did in red, the denominator in blue. So then this numerator I'm going to do in red, that's BA. So hopefully, do we all get that that has to be compared to this guy right here, the little triangle? So that should have been a G. All right. One more, 18. Do 18, and then we'll call it a day. And what do you, Cam?
I got E.
Good. Me too. So we did CB in the red, that's here, and then the BA. When you look on the other side, the denominator was given to you. So the denominator I had done in blue, so that's the EF. So then this guy right here would have to be what we compare to segment CB. All right. All right, bring this today or tomorrow. We'll finish it hopefully tomorrow, and then I'll let you know if we'll come back on a Monday and test on this or not. All right. So if you're home, you guys are good. You guys can go ahead and check out. If you're one of the people who need to make up the quiz, please see me second period today or tomorrow. Yeah.